All right, thank you. I'll explain the Potemkin village part in a second. So a Potemkin village is any construction, literal or figurative, built solely to deceive others into thinking that the situation is better than it is. Welcome to DevOpsDays. So everybody here tells their story about how awesome things are and what they've done and what they've learned and what went right and how they all improved. And you have high-performing teams and they're all high-fiving and loving each other. And that stuff happens. That's real. But there's a darker side to all of this that no one shares at conferences. And that's all the problems and failures and setbacks and things you did wrong and things that just didn't go the way you wanted them to. And that's what I'm going to talk about. So we're going to bypass the echo chamber of DevOps Days where we're all hearing about the love fest and the culture and great things. And we're going to go right into shit, it happens. So a Potemkin village was actually from Grigory Potemkin in the 18th century in Russia. He was basically some type of political leader over the Crimean Peninsula in Ukraine, but he was in love with Catherine, the leader of Russia at the time. And to impress her, wherever she would travel through Crimea, they would build these fake towns so that it looked like she was going through these wonderful villages and that everything was spectacular in the Crimea. And then they would tear them down, and they would rush ahead of her caravan and build another one in front of her 2 days down the road, and that was a Potemkin village. This is still a phrase used. It actually came up a lot again in the Winter Olympics in Sochi, because that's where that picture is from. Just saying, it kind of happens sometimes, I guess. But anyway, the idea is you're presenting something that's not really there as way better than it is. But we're at DevOpsDays Rockies, and so we'll share some of that stuff. About me. I'm Mike Stahnke. Several years ago, I wrote a book on SSH. I do care about all things security and operations. My background's in release engineering, operations, security, basically anything that's not development. So what do? Obviously, I run a team of developers. You can follow me on Twitter. I say stupid stuff on the internet. I was also one of the people that put EPEL together, the package repository, back in the day. So anyway, there's a lot of books on DevOps. There's a lot of material out there. There's a lot of stuff that tells you this is the way you need to roll. This is how you want to act. This is how you want to improve. And a lot of those have really great ideas in them. None of those are bad. But just because you have a map of how to get somewhere doesn't mean it's easy. This is the longest walk you can take in the world, by the way. It's about 8,000 miles. Just because you have a map doesn't mean it's easy. Not only do you have to cross deserts and mountains, like the Sahara, but you're also going through some heavily contested territory in the Middle East. It's just not going to go that well. DevOps, right? So let's talk about some principles that I have. When I define DevOps, I basically mean the way you work. And maybe that's a really, really simplistic way of saying it, but the other way that I like to say is DevOps is just working together. And you can have all these other definitions or whatever, and they're all right or wrong or whatever. I don't care. Working together. One thing that I will caveat is that DevOps is not the same thing as CI and CD. You can do CI/CD without DevOps. You can do DevOps and have nothing to do with CI/CD in your world. I will, of course, conflate them often during this talk. So, best practices. One of my principles is that I don't believe in best practices because best implies you have context that I don't have. So if I have ideas or things that didn't go right, I don't know. I do believe in worst practices, and I will tweet about them often. But basically what we're going to cover are a bunch of things you probably shouldn't do, and ask me how I know. So we'll call those anti-patterns. Now, as a disclaimer, I work at Puppet. I'm not going to try and sell you Puppet, but you should definitely buy Puppet. The thing that I want to be clear on is, I have a little bit of trust here in that I'm going to share things we did very wrong. I don't want that to belittle the confidence you have in this company, if you have any, because a lot of it's better now. And also, there's a whole lot of stuff that goes right that I give lots and lots and lots of other talks on. This is just the anti-pattern talk. So we ship software. We ship it on-premise. And so that means we don't have the luxury of deploying 10 times a day to the customer, because even if we did that, the customer has to adopt those 10 releases a day, install them, get the upgrades going, and all that. In other words, we deliver software to you. We have this update problem where we're not sure if you're going to take the software. I mean, people are still running Puppet 3 or Puppet 2.7, and those were end of life 4 years ago. And, life moves on, but they don't. So that happens. basically, that's a long way of saying the cost of being wrong is very high in my world. And that's one of the great things about CI/CD is usually the cost of being wrong is much lower because you can just ship again. Oh, we messed up that thing. We'll reship or revert or whatever. When the cost of being wrong is high, you operate with different patterns. And some of them are just terrible, and we'll get into that. But I'm going to break this down into like a classic DevOps taxonomy, which is the CALMs: culture, automation, lean, measurement, and sharing. I apologize to whoever I ripped off this slide from because I definitely did not draw it. But starting with culture, culture is the way we work. But then I said DevOps was the way we work. That was not a coincidence. Those are almost the same thing. But, so we start at Puppet, right? And we have a culture. And our culture is actually really, really science-based. Our founder and CEO, original, Luke, is a scientist. He's a chemist by background. And so everything was, what's your hypothesis? How do you prove it and measure it? Okay, that's not a bad cultural foundation to start with. So my hypothesis is that this build artifact is shippable. What experiments do we run to prove otherwise? Well, that's the entire delivery pipeline, testing, building, all that stuff. So our goal was to get to something that looked like this, right? And this is out of Jez Humble's continuous delivery book. And it was, even if we don't ship every release out to customers, we want to be building multiple times a day and having tests and having it validated and knowing that things are great inside of our commercial flagship product. Okay, all makes sense. This thing even makes sense. Reading the continuous delivery book makes sense. It looks a lot like this from where we started, right? I've got a map. I know where I want to be, but holy cow, I have to, run across the Gaza Strip during a war to get that to work. So let's just start with our organizational structure, right? We were in a kind of a classic layout. We had dev, we had ops. Cool, all right. Now the problem is at Puppet, everybody in dev thinks they're a better sysadmin than you are. At least they did 7 years ago when I started, because we were a company of a bunch of sysadmins. Wow, you want to talk about some cultural friction? Can you imagine all the developers telling you all the things you're doing wrong when you're configuring a server? Like, usually they don't care. They're just like, just give it to me and I'll go take care of it. No, here, oh my God, why did you set up Emacs as a default editor? It should have been Space Emacs. I mean, like, it's just like, wait, that's the thing you care about? I wanted to just run software. And so, and this ops team was also responsible for like back office stuff, finance, sales, marketing, Salesforce administration, just all that. The stuff that like really isn't very involved with dev, for the most part. Okay. So what we did was we had dev and we had ops and also ops. And I ran that team, the also ops team. And they were really good at it, I'll tell you that. But that also meant we had some misincentives, right? We had an ops team that didn't, like the gray ops box, didn't really meet our needs a lot, so we did our own thing, except for when we couldn't. Like, we didn't have access to data centers to go put stuff in there sometimes. Or we needed something that was, maybe a DNS change, and we didn't have the account rights, or something in Linode, and we didn't have the account rights. And so we'd do all the ops up until the point we couldn't, and then we'd just get mad. Awesome. So at the same time, we'd publish our State of DevOps report every year and talk about all this teams and organizational structure and everything's going right and how you should do it. And we were like, hypocrites, that's the word. So then we were like, all right, this is the common pattern. We're seeing lots of people do this. Like, we have a DevOps team because we have this ops org and we have this dev org. Only at our company, we renamed it to SRE. And the reason we did this is because if you search DevOps on our internal network, it all comes up with all marketing stuff, and you couldn't find anything about how to actually do work. Fun fact. But really what it looks like today is SRE is much more in dev. It does have some overlap with kind of the classic IT stuff, but then we also have IT that's more servicing outbound other back office and business technologies, and they do own data center. Now, is this perfect? No. There is still a set of trade-offs here. There are still like, things you throw over a wall, but it's okay. It's improved. In dev, we've gone from all the devs do things. Well, we have more of a cross-functional team. You have like your testers and your doc writers and all these, sometimes release engineering or quality engineering all in there. That's cool. But one of our other patterns kind of from an org statement is like our teams were just too large. When you put a cross-functional team together and you decide you have 7 roles that every team needs before you even get to engineer, you end up with teams of like 15 or 20. Have you ever tried to move fast with 15 or 20 people? I can't decide how to go to lunch with 5 other people, let alone build a product. So that was hard. And it's like Roger Waters up in here in that there's a lot of walls we're throwing things over. Let's just say that. That's a Pink Floyd joke for those of you that don't get it. Okay. No. And our working style, what it ended up turning into was waterfall in 2-week increments. And that was really rough. It's really hard to be good at waterfall, period. It's really, really hard to be good at it in 2 weeks, over and over again. But we did it, so. Automation. I'm going to get back to some of the solutions at some point, but first I'm just going to go down the terrible road because it's way more fun. So automation, right? Over-the-wall mentality, like I said. So it was like, hey, I'm just going to merge some stuff and hope it's okay. And that was basically how a lot of things were developed in, not at the component level, which component is like small piece of software, but at like the composite layer where like everything comes together and meshes and mashes, and like that's the bigger commercial product, basically like the equivalent of like stamping an ISO. At that point, it was like, let's just stamp it and we'll see if we run it and see how it goes. So we had late stage QA. And QA would sit there with, you know, a team of between 15 and 30 people, depending on when in the world we're talking about in Puppet history. And they would test this stuff, and they'd find great stuff, and they'd do exploratory testing. And actually, I mean, they were a really good QA team. The problem was they were so late in the stage that if they found a significant bug, particularly if it was a design flaw, you couldn't react to it. And of course, our CI system was red. We have a very advanced CI system. It was really good at outputting red balls. We had a lot of them. So we had like this kind of tragedy of the commons on mainline. It was like mainline was red, but no one knew why, because everybody was just saying, well, my stuff's probably good, they'll validate it later. And they just kept merging to it over and over again. And so basically it got to the point where the CI system, it wasn't like this system that told you anything, it was just a red light on the wall. And that's okay. I mean, for some definitions of okay. It got better. But it came down to in failure we trust, right? So if everything is just failing, I don't have to do that much work because somebody else is going to go figure it out later. And so that meant a lot of things thrown over the wall. It meant, well, it'll get fixed in integration, or it'll get fixed in test, or it'll get fixed, you know, in deployment, or in exploratory testing, or whatever it was. And it did get fixed in all those spots. Like, I'm not going to say that we shipped some great software during this time. Just the way we did it probably could have been better. We also automated some bad processes. Like, we were an automation company. We're like, all right, let's go all in on automation. The problem is if you have a terrible process to start, all you've done is made terrible things happen faster. And that's what we did. This is an actual picture of our CI pipelines and how they worked. There was, I mean, today that big auger's out of there at least, but the rest of it, no. It's still a really complicated CI system. When you ship for 90 targets and architectures, you have a lot of if statements in there, right? Who wants to run on AIX 5.3? That's been end of life for 2 years. Oh, we do, apparently. You know, who wants to run on Spark? Who wants to run that network switch that's in the corner? We do all that. And sometimes that means that our CI system has a lot of variables and complications. And basically you end up thinking that everything is terrible. This became a meme of engineering overall. Everything's terrible, computers suck, I hate computers, why do I do this to myself? And eventually you're just like, dude, if you hate everything, go find another job. Like, and it's not that I wanted people to leave, but like if you really have this much hate and this much negativity, do something with your life you enjoy. I don't want to be the bane of your existence. And so we had all these factoids in our hip chat channel, and Terminator's our bot, and what I love about this is it's a piece of carp. Like, we couldn't even spell crap right in this factoid. And this is active today. I pulled this screenshot this morning. So, but we kind of just came back to like this, hey, you know, CI's tough, everything's terrible, our Jenkins installation isn't good, it doesn't do what we want, blah, blah, blah. And part of that was in our special sauce for Jenkins, we had all of this logic. And I don't know if you've ever tried to just paste stuff into like text areas, and that was where all your logic was that wasn't versioned, and you couldn't see who edited it or who changed it. Because who puts authentication on their Jenkins servers? Seriously? So you have no idea what happened, right? That was our special sauce. And it would exit 0 if it couldn't figure out what was happening. Oh my God, CI's green. So the other thing was there were just some things we needed too quickly to automate, which is like this counterintuitive statement, but like a GPG key expires. You need that key up on the signing server like yesterday. Oh, we don't have an automation to deploy that GPG key because it's been there since the old ones ruled the CI system. And now we have to get it out there. All right, I'll SCP it over. I put it over there, and oh, that box gets blown up 4 years later. You rebuild it, you run Puppet on it, and suddenly that key's not there anymore. And you're like, huh, probably didn't do that right. We would definitely not tell customers to do things that way. All right. And then we had this problem of every time we got a new build, what changed since the last build? What things are significant? Why do I care? And basically, if the mentality is merge and then hope, you kind of don't know what's there. So that's, oh, I forgot about this. And we have a code freeze period because during that late stage QA and validation, like we can't be putting new changes in there that aren't authorized by 17 parties. Because if we do that, then I won't know what changed, and then I'll have to validate something that I didn't know about, and then we start all over, and then Jenkins is red. So obviously we're awesome at automation. Now let's get to the lean part. Our cycle time was measured in days, right? Which if you're building a car at Toyota, maybe not terrible. If you're building software and you're a dev and you want to, let's just say you want to bump the version of Ruby from like 193 P147 to 152, right? All right, I'll find out 3 days later if that was a good idea. Awesome. So we had some issues there. We would also see a lot of partially complete stuff put on the main line. And this is where you have two choices, right? You can double down on trunk style development, or you can branch for everything. Obviously, we did both. So, but partially complete features are, you know, things like you try and spin up a new feature, or you try and go to a UI, and maybe like the left nav loads, but like the main part of the page doesn't load, and that's not shippable. So we weren't always shippable. And when you're not always shippable, you have issues of, you know, well, I can't hand this to a pre-release customer right now, or I can't go to my partners, or I can't train my pre-sales people on this because it doesn't work. And so then we got to this thing where we'd flag certain builds as fairly usable, and people would grab those for training and stuff like that. And you know, a lot of this was, we evolved. We were a 30-person company when I got here. A lot of this happened organically. We were growing very fast. Like, these are decisions that we made for the right reasons at the time, and I promise you that. But your journey isn't necessarily my journey. We also had too much load on the system. Our back-end CI system, at any point, I'm going to say it ran about 2,000 jobs a day, went through maybe 10,000 VMs, 12,000 VMs a day. Still does, but it used to too. But too much load on the system in that we had like all these different entry points and we couldn't throttle. And so if you had 9 jobs that each wanted 1,000 VMs and you couldn't handle that all at once because you could only do 2,000 at one time, well, things kind of start to have problems because resource contention, things fall over, things are breaking. And so this system, which by the way, I care immensely about our CI system. I will sidebar on this or open space, whatever you want later, because it's really good now. And then from a measurement standpoint, we really didn't take a ton of measurements because if we can't respond to feedback, why do I care about what measurements I have, right? If you can't do anything with the measurements, don't. But we did have this mantra on the ops side that was, if it moves, capture it. Unless that's hard. Because sometimes there are metrics that are like that you really want, and it was like, okay, what tests are using the most VMs, and what time do they run, and why are they scheduled at this time versus when this other group of tests is doing the same thing? And it was like, wow, we actually can't answer that question without going to build a few things and going to capture a lot of log data. And like that was the metric I wanted. I didn't want, you know, everything that StatsD just gives you by default always. So then we had all this data from ops, but we did nearly nothing with it. What we did do was increase our storage bill. So that's something. From a sharing perspective, complaining is sharing. So we were excellent at sharing. But we did celebrate and we shared our successes. I mean, there were things that we were really proud of that we did well. There were things we shipped some great software. We had some great releases of Puppet in there. And we were doing it with, maybe a late stage QA or more waterfall style model. That's okay. We did ship good stuff. And the thing is, there are dozens and dozens and dozens of great talks about what Puppet does right or what the industry does right. There's conferences devoted to it. And all those things happen. And I mean, if you want to see other talks I give about awesome stuff we do in CI and stuff, they're there. So again, I'm only talking about the bad parts because that's the point of the talk, not because everything actually is that terrible. So some solutions to some of these problems. If everything starts on the right, you can only shift left, right? Because if the first step in the pipeline is merge and then figure everything out, what if merge wasn't the first step? Like, I could know this thing worked before I put it on mainline. And it took us a lot of tooling to do this the way we wanted to do it. It took us a lot of investment because organizational inertia is a thing, and overcoming it is a thing, and cultural change is a thing. And it just took us a while. At the component level, a lot of this was already going on really well. This is at like the composite commercial level, where all the components come together and build, Puppet Enterprise. And it was just like, hey, we could check this out before we merge it. That's pretty cool. We could put QA with dev so that we have test cases and test cycles and testing happening long before it's kind of all assembled in the final product, and then we have to figure out which commit caused that issue. I will say that most of our engineers and QA people were very good at git bisect by now, because we had to find this stuff. That's not a skill set that like a lot of people want to get super good at usually, but we're there. We started running mainline in the ops group or in the SRE group sprintly. That changed a lot of things. That was a forcing function. I'm going to deploy this come hell or high water every other Wednesday. That's a production environment. It better fucking work. Because if it doesn't, I can't manage change. I can't deploy new things. I can't make DNS updates. You might not be able to register for PuppetConf. Like, there's a lot of things that actually fall out of that. We had more change in the first 4 weeks after doing this than we probably had in the 2 years prior to that. So we had a forcing function. And everybody said, you're not going to be able to do it. It won't work. And I gave my team, I think I gave them 9 months to do this. And they did it in a month and a half. So once you had a forcing function, it really, really, really helped. CI now has meaning. If it's red, something's broken. It could be, something on the infrastructure, like a transient error, a networking problem. It could be a bad test, because we've all written those. It could be bad code. All of those things happen. But if it's red, it has meaning. We swarm on it, we fix it, we get it back to green. I mean, you've heard this story before, but how do you get there? So now, if you go into our HIP chat and you say CI, basically it says, it's a really hard problem that many fine folks are working really hard to solve in the best way that we know how. And that's the truth. Our automated delivery pipeline is super challenging. It's big. It's got tons of if statements, tons of branches. And we're doing the best we can on it. And I would say it's really darn good at this point. But are we satisfied with it? Of course not. We started throttling the system. We have a scheduler on the back end now that looks at all the jobs that are coming in and what resources it requests to have those jobs. And it'll do things like, hey, if you need 600 VMs right now, I don't have those available. You're just going to go in a wait queue instead of just grabbing the ones you could and then failing, which is what used to happen on our system. We use feature toggles on mainline. So if it's not shippable, you just toggle it off. But you can still commit. You can still get it reviewed. You can commit in sections, small batches, all the stuff you're supposed to do. And the culture shift was, this is shippable. The hypothesis was now more often true than not. This is shippable. We can run this. We can put this in production. It's going to go in production next week. I better be pretty sure about it. I know this change set is good because I've done validation on it before this change set went in. Our culture change also was more shipping is learning. I can get feedback. When our SRE team runs Puppet Enterprise, sometimes they find things that didn't work as designed, or like the feature just it didn't shake out quite right. I'd much rather have us do that internally than you go deploy that and you tell me that. Because if I knew that, then I didn't need to hear it from you. So we can fix it. We have time to react to some of those problems now. Now, that's not to say that we're issue-free. Those are some of the solutions we've had. But we still have issues. There's always the next bottleneck, the next problem set that you're trying to tackle. We still apply the scientific method to all of them. So usually when things are going on, I ask, what's the cost of being wrong? How fast can we move? That's another way of saying that. You can move a lot faster if the cost of being wrong is low, because you can make adjustments to correct it. If the cost of being wrong is very high, well, take more care. So until very, very recently, like in the last 30 days, we were doing perf testing late stage, still like we did with QA. It would be like you kind of assemble everything, and then we're going to do performance characterizations. And most of the time they went in our way. Like it wasn't like we got these huge performance bugs we found late stage very often. Not never, but it wasn't that often. But we just put a team on it and said, hey, this needs to happen way earlier, like before merge. We need to know performance characteristics on at least subcomponents. So that's going well. It's not perfect yet, but it's going. We have too many tests, which is a weird problem when you think about it. But if I test that I can exec something, which is basically just shelling out to bash on Red Hat Linux Enterprise 5 32 bits, do I need to run that test on Red Hat Enterprise 5 64 bits as well, and ARM? And the answer is, it depends. Do you trust your code bases? Do you think the behavior is the same? Is the API the same? Does the OS behave the same way? And we haven't gone through that analysis. And so a lot of times we run these tests on 90 targets that are almost the exact same, that basically it's either going to fail all of 90 targets or 0 of 90 targets. So it's not a very meaningful set of tests at times. We also have issues where we don't have the right test coverage. Puppet at one point had 20,000 some odd unit tests. I think it's a little bit lower than that now because we deleted some stuff that was pretty duplicative. But there were still certain areas that were actually pretty light on test coverage. And that stinks. Like, that's hard. Anybody who tells you that testing isn't the hardest part of continuous delivery has not done continuous delivery. I just want to say that. And so we started forming teams around problems. This is another one of our current issues, is when we have a problem, we're like, let's build a team to go solve this. And what I'm really trying to push as a leader is, let's hand that problem to a team that's already established. Because I don't have to reform a team and go through all that team formation thing, and they don't have to go through the churn of, whether it's a reorg or an organizational alignment or a new team formation or whatever you want to call it. But let's hand a problem to a team rather than building a team for a problem, because that team will be short-lived then. Some of these mistakes we've learned multiple times, or solutions, or whatever. In Puppet Enterprise, the code base is largely Ruby and Clojure. And so we learned a lot of this stuff. And with some of our newer products, we have different languages or different tool chains and different sets. And sometimes we're making the exact same mistakes again. Because there's a natural state and there's a natural flow for how things go. Now, luckily, we can recognize them sooner. We know the solutions. We know the patterns to move forward. But those things happen. So a few final thoughts. Nobody is the best at DevOps or software. There's literally no one. If you went up to any engineer at any company and said, are you the best? I think everybody would say, no, we're not. There are people that do certain things really well. There are people that advertise about how they do things even better. But nobody's the best at this. My suggestion is to reduce the number of variables you have in play. Anytime you can do that, fewer if statements, fewer branches, fewer logic flows, your life is going to be better. Like, what if that walk from Algeria to the eastern edge of China, didn't have to go through all of Africa and the Middle East, and you just had to walk across China? You're like, wow, that's still really hard, but that is so much better than having to walk across the Sahara. So you need to have a ruthless pursuit of improvements. And that means dedicating engineering time and operations time to improving systems you already have, improving process you already have, improving culture that you already have. And this is not easy. This is a story of a 7-year journey and change and problems, and some of those problems are still active, and some of them are things I can laugh about on a whiteboard. But they're there. It's just not easy to do a transformation of software delivered to people that they want to use, that they want to adopt, that they want to upgrade. Like, I don't know. That's pretty hard. So you need to optimize for progress over for perfection. I don't want to see perfect. Perfect is the enemy of good. I need to see incremental change, improvements. It better be better today than it was yesterday, and so on. Organizational inertia is such a powerful thing. And I've underestimated this as, Puppet's a 10-year-old company, basically, and really it's about 7 years when it's had more than 3 employees. And we have so many little things in our DNA that are so ingrained. And it's crazy to me, because the last company I worked at was an 85-year-old company, and I understood when they were stuck in their ways. But when you're like 7 years old, and you have all these things stuck in your ways, like, it's weird. But then I have a 5-year-old kid, and I'm starting to get it. It's all making sense. But basically, like, there's a reason we don't have bullet trains everywhere in the US. And it's because we made all this investment in interstates, right? And so other countries that didn't have interstates, they jumped right to the coolest thing. They jumped right to bullet trains. They don't have all that. They went to wireless networking right away because they didn't have a copper infrastructure. The way things used to be done is very, very powerful. And that's the same for an organization as it is for a government or a society. So this is a DevOps maturity model, and it's bullshit. And the reason is, like, I don't even know if I've read the entire thing, but the last one on the top says DevOps done. Done is a myth. Like, done? I'm done with software. I'm done with DevOps. I'm done caring about the way we work. Give me a break. That's not how this works at all. You won't be done. There is no done. Done is a myth. I think there's a quote about software that it's done when the last user has uninstalled it. I don't even think that's true, because somebody else could still install it. So my final thought is, the thing that you really need to optimize for is getting better at getting better. That's how you win. Like, you have to improve constantly. So I've shared a lot of, I guess I'll say, inside baseball for the way Puppet has worked over the years. I'm still very, very proud of every release of software we've had. I'm still very happy with everything we've ever done. And I'm happier that the ways that we have problems today are very different than the ways we had a year ago, or 2 years ago, or 3 years ago. And I hope that most of you have a journey that's similar, where you're better today than you were before. You're more proud of the things you did today than you were before, but you were proud of them at the time, too. And that's not to say that anything that we're doing is wrong. We all have these journeys. We all go through them. Anyway, that's my Potemkin village of DevOps success. Thanks.
Awesome. Thanks, Michael. Okay, who has questions? Anybody? Y'all don't realize how much I really want to throw this thing. Oh, gosh. All right, this is it for you. I'm going.
So can you talk about your forcing function a little more? It sounded to me like before that, people were merging into, I think you called it mainline, kind of carte blanche, and then you took it down to once every 2 weeks.
Not exactly.
Okay.
Maybe I wasn't clear on that. So we used to have, people would merge, and then we'd go validate, right? It was merge and then figure out if that was a good idea. And then we wanted to go to, hey, this is a good idea, let's merge. That was kind of the process change. The forcing function was somebody was going to deploy that every 2 weeks. And so we were merging all the time. We were doing 10, 12, 15, 25 builds of Puppet Enterprise a day. But if they weren't being run, they were just being validated, that was one thing. But now we knew that we had a real customer that did real work using that software, and they were going to deploy it every other Wednesday. And that meant it had to work. So it kind of forced us to think about that entire process from the end all the way back to the beginning.
Thanks.
Yep.
There you go.
As the box controls the next question asker.
How do you use the box? So you talked about moving things left. Are there places where you moved something left and decided that sacrifice was not worth it? You paid for something else. Was a shift left ever a negative?
Not that I can think of. They all have trade-offs. Like doing perf testing earlier, my EC2 bill is going to be a little higher, right? Because I'm going to do it more often. So it's got a trade-off, worth it.
So you talked about too many tests, and your example was running the same tests on all the OSs. So my question is, in my experience, the things that are going to trip you up are usually when you make those assumptions, but also I see what you're saying about that taking a lot of time. So did you turn those tests off completely and say we're going to run this exec test once, or did you say we're only going to run this exec test once for a frequent build and do like a regression build that runs the whole thing?
Yes to all of those. We've had many different experiments in this space. Like, we had tiering where it was, okay, we're going to run all these on commit, and we'll run this other set nightly. Or we have this, we're going to run all these on commit, and this other set goes only weekly or bi-weekly or whatever. We've done things where if a test hasn't failed in a long time, we're going to move it like the frequency of how often it runs. But, I mean, the right answer there is still I don't know. Because to me, if I only run something once a week, my cycle time is technically a week. And that's not okay. So we keep working on how we're going to make those changes and trade-offs. There are other times where we turn off tests for a while, and if something fails that test would have caught, we turn it back on. So.